Here is 3.5 quadratic functions, maxima and minima, day 1. We are working with the quadratic function, starting with the format of ax squared plus bx plus c. And when we have this format, to find the vertex, we want to start with the fact that x is found by taking the negative value of b over 2a. So we have been working with the form of the vertex where we would have f of x equals something like x minus 2 squared plus 8. And we would set this inside equal to 0 to find the x value, and you would find x equals 2. And when you plug in 2, you would get 0 plus 8, and you would find out that y is equal to 8, and your vertex is 2, 8. Okay, so we've been working with the function in what's called standard form, but to start out this section, we are going to be working with this format. And so one way to, instead of having to do any work to convert this over to any different type of form, we can simply use x equals negative b over 2a. And knowing that once you have x, you would plug that into the equation to find your y. And so your vertex is essentially the negative b over 2a for your x value, and then the function evaluated at negative b over 2a is your y value. Now, the other thing to consider here is we also call the vertex to be the point at hk, kind of like we did with the center for a circle. The vertex of a parabola is going to be represented by h and k. And so one way to think about the x value of the vertex, it's h, and the y value of the vertex is k. A couple things to know about a parabola and the vertex of the parabola is that when a is greater than 0, the vertex is at the bottom of the parabola, and the vertex is the minimum of the graph. And the minimum is just found by starting with x equal negative b over 2a and finding f of negative b over 2a. The y value is considered the minimum, or actually the maximum, depending on the graph. But you have to understand that you start with the value of x so that you can find the y. So really, once you find the vertex, you already know the minimum or maximum value. So when x is greater than 0, you have the minimum, and when when a is greater than 0, you have the minimum value, because you have a parabola opening upward and the point is at the bottom. I call that a smiley face because a is positive. So when a is positive, if people are positive, they're usually happy and they're smiling. Okay, and so you have a smiley face, the vertex is at the bottom, and you have a minimum. So when a is less than 0 or negative, it's sad. It's in a bad mood. It's got a frowning face, and I call it a frowny face because it's like a sad face. Okay, so we have either a smiley face or a frowny face. Smiley face is when a is positive, and the frowny face is when a is negative. So when we have a frowny face, the vertex is at the top of the parabola, and it is a maximum value. The maximum is found, again, starting with your x and finding your y by plugging in negative b over 2a, and again, that's your y value. All right. When we look at curves that are not quadratic functions, but we have peaks and valleys of a graph, the local maxima, the high points of the graph are called local maxima, and the low points of the graph are called local minima. So if you're looking at a graph and they want you to identify the local maxima and the local minima, you are identifying these points. And if you're looking for local minima, you would be identifying these points. All right, let's look at an example here. In this example, we need to find the coordinates of the vertex. We're going to start with x equals negative b over 2a. We need to find the maximum or the minimum, which is then finding, once we know the vertex, we find the function evaluated at negative b over 2a, and we know that we have the maximum or minimum based on a smiley face or frowny face. We need to find the vertex, which is the x-intercept, find the intercepts, which is the x-intercept when y is equal to 0, and the y-intercept when x is equal to 0. And then we need to graph this. So we have this function, negative 3x squared plus 6x minus 2. A is negative 3, B is 6, and C is negative 2. So the fact that A is negative 3, we know that this is a frowny face and the vertex is at the top of our parabola. So we know that we're going to have a maximum. So when we get to part B, we're going to be finding the maximum. Starting with part A, I'm again using x equals negative b over 2a. B is 6, so negative 6 over 2 times negative 3. That is going to give us negative 6 over negative 6, which is 1. So x is equal to 1. To find the y, I have to evaluate this function at 1, so f of 1. So I get negative 3 times 1 squared plus 6 times 1 minus 2. 1 squared is 1, and negative 3 times 1 is negative 3, plus 6 times 1 is 6, minus 2, which is 1. So y equals 1. So our vertex is 1, 1. Part B is to find the maximum or minimum. Well, we know that because a is a negative number, we have a maximum, and the maximum is at x equals 1, and the value is 1 because of y equal to 1. All right. Part C is to find the intercepts. The y-intercept is very easy. It's just when x is equal to 0. So we plug into the function f of 0. We get negative 3 times 0 squared plus 6 times 0 minus 2. Anytime you plug in 0, you're canceling out that term. And so f of 0 will equal negative 2. So my y-intercept is negative 2, or as an ordered pair, 0, negative 2. Now for my x-intercept, that is when x is equal to 0. Y. That's when y is equal to 0, which means 0 is going to equal negative 3x squared plus 6x minus 2. And in this case, we could either try to factor this quadratic, or we could just use quadratic formula. In the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. We've already identified a, b, and c, so we're going to have x is equal to negative 6 plus or minus the square root of b squared, so 6 squared, which is 36, minus 4 times a, which is negative 3, times 2, which is negative 2, all over 2 times negative 3. Once we simplify underneath the radical, we will get 12. And the bottom, the denominator, is 6, negative 6. Okay, the square root of 12, okay, we can simplify that because we get 2 times, if we do the factor tree, we get 2 times 6, and 6 is 2 times 3. Well, we're looking for pairs of numbers, and 2 times 2 is 4. Well, the square root of 4 is 2. So we are going to get negative 6 plus or minus 2. And then the 3 by itself is going to stay under the radical. So we get 2 times the square root of 3. And that's over negative 6. So the fact that negative 6, positive 2, and negative 6 all have a common factor of 2. And since this is negative 6, I'm going to take out a negative 2. I can factor out negative 2 and be able to simplify this. So I get negative 2. Inside, I will get 3 plus or minus the square root of 3 over negative 6. And negative 2 over negative 6 will cancel out to be 1 over 3. And then I will get 3 plus the square root of 3 over 3. And I will get 3 minus the square root of 3 over 3. And I can simplify this by splitting this up into 2 separate fractions. And 3 over 3 is 1. And the square root of 3 over 3 is just the square root of 3 over 3. And that value as a decimal is approximately 1.58. When I simplify this other radical or answer, I get 3 over 3, which is 1, and then minus, and then again, square root of 3 over 3. And that as a decimal is 0.42. So as an ordered pair, we would write 1 plus the square root of 3 over 3, comma 0, and 1 minus the square root of 3 over 3, comma 0. And those would be my x-intercepts. Oops. Okay. Now we're going to graph this. So to graph this, I'm going to first start with my vertex. My vertex is 1, 1. So I graph 1, 1. And then, knowing that it's a frowny face, so I know it's going down, so I can check my work here as I'm going through here. But the next thing I want to graph would be my intercepts. So my y-intercept is 0, negative 2. And that's 0, negative 2 right there. I could try to graph these, which is why I put 1.58 and 0.42. Well, that's a little bit less than half for 0.42 and a little bit more than 1.5 for 1.58. The other thing to consider is that parabolas are symmetrical. So if I put like a line down through going through my vertex, I can create a line of symmetry. And looking at my, an established point like my y-intercept, I see that that's 1 unit away from that line of symmetry. So if I stay at the same value of y and just go 1 unit away on the other side of the line, I can use symmetry to graph another point. And then, knowing what parabolas look like, I can graph down through my points and kind of have this curved, um, you know, curvature. Don't make it a point up there because parabolas don't make points. Do make it a curve as you go through the vertex. And that's my graph. Okay, so that was part D. So I did part A. I found my vertex at 1, 1. My maximum, I had a maximum at the value of 1. My y-intercept was 0, negative 2. My x-intercepts were 1 plus the square root of 3 over 3, comma 0, and 1 minus the square root of 3 over 3, comma 0. And then I had my graph. Okay, And that's it for 3.5 day 1.